What if some black holes weren't born from stars, but from the Big Bang itself? This audiobook explores the hypothesis of primordial black holes, objects formed in the earliest moments of the universe, when the density was so extreme that small fluctuations could collapse on their own. A mystery that could explain everything from dark matter to the very origins of the cosmos. The importance of primordial black holes lies in their potential to give us clues about the earliest moments of the universe's existence. While the black holes we know, those that form from dying stars, have been studied in depth, primordial ones are a completely different category. Imagine a tiny black hole, perhaps no larger than an atom, created in an instant of high energy. What would this mean for our understanding of space and time? In addressing the nature of these black holes, we face astonishing questions. What characteristics do they have? How do they differ from other types of black holes? These holes are not only fascinating for their existence, but also for what they represent in scientists' struggle to understand the forces that shape our universe. As we delve into their definition, we will see that primordial black holes can exist in a variety of sizes and masses, making them even more intriguing. The black holes we know are usually the result of the collapse of massive stars. But can there be black holes that have never had a star from which to derive? This is where primordial black holes come into play. Their origin is linked to events that occurred in the fraction of a second after the Big Bang, a time when the universe was in a state of chaos and extreme density. This context helps us understand why primordial black holes are so different from their more familiar counterparts. The differences in the formation of these black holes are fundamental to understanding their nature. While conventional black holes form from the death of stars, primordial ones may have arisen during the quantum fluctuations that occurred in the primordial universe. Imagine the universe as a boiling pot of water, where bubbles of density appear and disappear. Some of these bubbles could have collapsed into black holes, leaving a dark legacy that still persists today. The diversity in the sizes and masses of primordial black holes is astonishing. From those that could be so small that they fade into nothing, to those that could have masses equivalent to millions of suns, their distribution in the universe is a puzzle that astronomers are trying to solve. How many of these black holes could be lurking around us, invisible, but with a powerful influence on the space and matter around them? As we explore the cosmos, another intriguing question arises. Where are the primordial black holes? Being so difficult to detect, they often go unnoticed in the vastness of space. However, their presence could be inferred through their effects on the surrounding matter. Even in the dark, their influence can be felt like a shadow that lengthens in the light of dusk. Primordial black holes are not only an isolated phenomenon, they also interact with the matter around them. Imagine a whirlpool in the water. Nearby objects are drawn towards it, spinning and swirling. Similarly, black holes can affect the matter around them, creating accretion disks full of energy and radiation. This interaction is a fascinating aspect that reveals how these mysterious objects can affect the structure of the universe. The connection between primordial black holes and dark matter has captured the imagination of many. Could these black holes be an important part of the puzzle that makes up dark matter? Their existence could offer answers to questions that have baffled scientists for decades. As we investigate this relationship, we delve into a territory where modern physics and cosmology intertwine in unexpected ways. Theories about the existence of primordial black holes are diverse and fascinating. From models suggesting their formation in the early universe, to indirect evidence pointing to their possible influence on the cosmic structure, each new idea brings us closer to understanding their role in the grand scheme of the universe. What discoveries does the future hold in this field of study? Curiosity about these topics drives us to keep exploring. The methods of observation and detection of primordial black holes are equally exciting. With the help of modern technology, scientists are looking for signs of their existence through gravitational waves and radiation. The next generation of telescopes and space experiments promises to open an even wider window into this mysterious phenomenon. The search for primordial black holes is undoubtedly a scientific adventure that could change our understanding of the universe. In summary, the exploration of primordial black holes is a fascinating journey that invites us to question and marvel. From their formation to their impact on modern cosmology, these dark objects are more than mere curiosities of the universe. They are key pieces in the puzzle of existence. Curiosity about these mysteries should be the engine that drives us to continue investigating and learning. After all, the universe has many more surprises in store for those who dare to look beyond the known. Primordial black holes are one of the most fascinating mysteries of modern cosmology. To understand what they are, we must first imagine the universe in its earliest moments after the Big Bang. At that stage, the cosmos was a chaotic, extremely hot and dense place. Among the many things that were happening, some experts believe that a very special type of black holes could have formed, the primordial ones. But what makes them different from the black holes we know? Conventional black holes are formed from the collapse of massive stars, but primordial ones do not have that same history. Their origin is related to events that occurred almost instantly after the creation of the universe. How is this possible? The answer lies in the extreme conditions that prevailed at that time. During the first microseconds, fluctuations in the universe's density could have caused certain regions to collapse under their own gravity, forming these black holes. Therefore, their existence could be a vestige of the cosmos' infancy. But what are the characteristics that define primordial black holes? First of all, their size and mass can vary enormously, from very small, with masses less than that of an asteroid, to gigantic, with masses equivalent to millions of suns. This diversity is one of the reasons why they are so intriguing to scientists. If we could see them, we would find that they do not have a one-size-fits-all. Some could be so light that they would escape our detection easily, while others could be so large that they could influence the formation of galactic structures. Unlike their more well-known cousins, the black holes that form from stars, primordial black holes do not have to follow the life cycle of a star. They do not need to explode in a supernova to be born. This gives them a unique nature and allows them to exist in a variety of cosmic environments where gravity and density can be different. But where are they exactly? It has been suggested that these primordial black holes could be scattered throughout the universe, often invisible and difficult to detect. Imagine that you are looking for a needle in a haystack, but this haystack is the entire universe. Although we do not see them directly, their influence can be detected through the way they affect the matter around them. Speaking of influence, it is fascinating to consider how primordial black holes could interact with the surrounding matter. Like a magnet, they attract gas and dust, creating accretion disks that shine brightly as the material heats up before being devoured. This interaction is not only spectacular, but it can also offer us clues about their existence. If we observe patterns of movement in the stars or the radiation they emit, we could, in theory, deduce the presence of a primordial black hole. Another intriguing aspect is their possible relationship with dark matter. Dark matter is that mysterious component that makes up most of the universe's mass, but we cannot see. Some scientists postulate that primordial black holes could be one of the explanations for this phenomenon. Could they be part of the solution to one of the biggest puzzles of modern physics? As we delve deeper into the subject, even more intriguing questions arise about the existence of primordial black holes. What evidence supports their existence? Through theoretical models and simulations, scientists have proposed various scenarios that could validate their presence. Although we have not yet found direct evidence, science often advances through inference and indirect observation. On the path to discovery, detection methods are constantly evolving. Gravitational waves, for example, have opened a new window to study the universe and could be the key to detecting these black holes in a way we had never imagined before. Each new technique that is developed offers hope that we may reveal the secrets that these enigmatic objects hide. Primordial black holes are not only fascinating in themselves, but they also represent a challenge to our understanding of theoretical physics. Their existence could have profound implications for theories like quantum gravity. Questions about how they behave on extremely small scales could lead us to a new understanding of the forces that govern our universe. In popular culture, these black holes have found their place in science fiction stories and movies, where they are often presented as portals to other dimensions or worlds. This representation captures the imagination, but it also reflects the real mystery surrounding these cosmic phenomena. Science and fiction intertwine, each feeding the other's curiosity. Thus, as we delve into the intriguing world of primordial black holes, it is important to remember that their study is not just academic. They represent a path to understanding the history of the universe and the forces that shape it. Each discovery about them brings us one step closer to unraveling the secrets of the cosmos. As we continue our quest for knowledge, primordial black holes remind us that, although there are many unanswered questions, each question is an opportunity to explore, discover, and learn more about the universe in which we live. Curiosity is the engine that drives science, and each new finding can change our perspective of the cosmos forever. In the vast and mysterious universe, there are hidden secrets that invite us to explore beyond what we know. One of these secrets are the primordial black holes. But how were they formed in such a young cosmos? To understand this, it is essential to travel to the beginning of the universe, when everything was in a completely different state than we know today. Let's think about the universe just after the Big Bang. a place full of energy and constantly moving particles. In this primordial soup, gravity began to do its work. In such a chaotic environment, some regions of space began to collapse due to gravitational attraction. But what does that really mean? Imagine a balloon deflating. As the air escapes, the remaining material is compressed and concentrated at a point. This is how the first fluctuations in the universe's density could have originated these primordial black holes. These black holes are different from those that form from the collapse of massive stars. Instead of being the result of a final explosion, primordial black holes are the product of extreme conditions in the early universe. But what were the conditions that allowed their formation? One of the keys is in the extreme density and temperature that existed at those times. In such a small space, gravity could overcome other forces, thus creating these mysterious objects. As the universe expanded and cooled, these small concentrations of matter became more stable. However, their existence is not easy to detect. Imagine trying to find a small grain of sand on a vast beach. That's how scientists feel when they search for primordial black holes. The detection methods are complex and require great ingenuity, but the search is fundamental to understand their origin. The formation of these primordial black holes is also related to the theory of inflation. This theory suggests that, in a fraction of a second after the Big Bang, the universe underwent an exponential expansion. In this context, small irregularities in matter were amplified, which could have led to the creation of these primordial black holes. Thus, an intriguing question arises. Could these primordial black holes have been responsible for the structure we see in the universe today? Some scientists proposed that these black holes could have been much smaller than the ones we know today, even the size of a mountain. But how could something so small have such a big impact? The answer lies in their immense gravity. Despite their size, their gravitational force could have influenced the formation of galaxies and larger cosmic structures. As the universe continued to expand, these primordial black holes could have merged, forming larger structures. But what would happen if one of these primordial black holes were found in our galaxy? It could attract matter from its surroundings, forming an accretion disk around it. This disk heats up and emits radiation, which could be a clue to detect them. However, the story of primordial black holes does not end here. There is also the fascinating possibility that they are related to dark matter, one of the great unknowns of cosmology. Could these black holes be the building blocks of the dark matter that makes up most of the universe? This connection opens up a range of questions about the nature of matter and energy in the cosmos. The idea that primordial black holes may have influenced our existence is astonishing. If we consider that the universe is constantly evolving, primordial black holes could have played a crucial role in shaping the cosmic landscape. They could have been the catalyst that helped form the first stars and galaxies. The formation of these primordial black holes is a reminder that the universe is a place full of surprises. Theories about their origin and existence are constantly evolving, and each new discovery brings us a little closer to unraveling the mysteries of the cosmos. Science becomes a journey, and each question we answer opens the door to new questions. As we explore these concepts, we face a future full of possibilities. Research on primordial black holes is an active and exciting field. Scientists are designing experiments and simulations to better understand these cosmic phenomena, and perhaps, one day, we may see them with our own eyes. The story of primordial black holes is a testament to human ingenuity and our innate curiosity about the universe. Through research and discovery, each answer leads us to new questions, and on this path, we find ourselves increasingly fascinated by the vastness of the cosmos. The pursuit of knowledge is an endless journey, and each step we take brings us a little closer to understanding our place in this wonderful universe. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. What are the differences between primordial black holes and conventional black holes? To answer this intriguing question, we first need to understand how these fascinating cosmic phenomena form and what distinguishes them in their nature. Primordial black holes are creatures of the early universe, emerging at very specific moments after the Big Bang. Unlike the black holes we are familiar with, which form from the collapse of massive stars at the end of their life, primordial black holes may have been created by processes that have nothing to do with stars. Think of them as seeds born in a cosmic garden before the flowers, or in this case, the stars, had the opportunity to grow. Imagine a boiling universe where density fluctuations in space-time become the raw material for these black holes. Unlike their stellar counterparts, which require a massive star and its eventual explosion, primordial black holes may have emerged from small disturbances in the universe's density, thus creating a variety of sizes and masses. Isn't it fascinating to think that some of these black holes could be much smaller than an atom, while others could rival the mass of entire planets? Now, what about their characteristics? Conventional black holes have an event horizon that, once crossed, makes it impossible for anything, even light, to escape. This concept also applies to primordial black holes, but here is where we find a key difference. The mass and size of a primordial black hole determine its influence on the surrounding space. A small primordial black hole could have a tiny event horizon, while a larger one could cause significant gravitational effects, trapping matter and energy around it. Let's consider how they interact with their environment. Primordial black holes, being so diverse in size, can affect the matter around them differently. In comparison, stellar black holes usually have bright accretion disks, where matter accumulates and emits intense radiation before falling in. Primordial black holes, on the other hand, may be less visible, with a more subtle interaction. This raises the question, could they be there in our universe without us even realizing it? Let's talk about their location now. While stellar black holes are often found at the center of galaxies or as a result of supernova explosions, primordial black holes could be more evenly distributed throughout the cosmos. They could be floating in the intergalactic space, waiting to be discovered, or even hidden in the dark matter halo surrounding galaxies. How many of them could be near us, in our own cosmic neighborhood? And let's continue exploring the idea of dark matter. Primordial black holes are often considered as a possible candidate to explain this cosmic mystery. As we try to understand what dark matter is, primordial black holes offer an intriguing solution. Imagine they are the shadows of massive objects we can't see, but that influence the structure of the universe through their gravity. Conventional black holes are easier to study because we know how they form and how they behave. But primordial black holes are a bit more elusive. Their unique features and different origin make them a fascinating focus for scientists seeking to understand the universe. What else is there to learn about these mysterious objects? The answer may lie in the next discoveries. As we delve deeper into the comparison, it's essential to mention the theories surrounding the existence of both types. While the formation of stellar black holes is well documented, the creation of primordial black holes is still at the heart of theoretical research. Simulations and mathematical models are constantly evolving, trying to unravel the secrets of their existence. At its core, the story of primordial and conventional black holes is a story of contrasts. One is the result of the death of a bright star, while the other originates from the whims of the early universe. This contrast highlights the diversity and complexity of our cosmos. Finally, we can reflect on the role they play in our understanding of the universe. The exploration of primordial black holes not only helps us understand their differences with conventional black holes, but also provides us with a window into the history of the universe. Each discovery in this field can open new questions, inviting us to explore deeper into the mysteries of the cosmos. So as we continue our search, it's vital to keep curiosity alive and ask ourselves, what else will primordial black holes reveal about the universe and our place in it? The answer to this question could change our perspective on the very nature of existence. And that, my friends, is just the beginning of an unparalleled cosmic adventure. How large can primordial black holes be? Imagine a world where the size of an object is not only measured in meters or kilometers, but in masses and densities. Primordial black holes are a unique category that poses fascinating questions about their size and mass, and how these dimensions can vary enormously in the vast universe. On one hand, there are black holes that form from the collapse of massive stars. These usually have masses that range from a few times the mass of the Sun to tens of times more. However, primordial black holes can be different. It is believed that they can have a range of masses that goes from as light as a handful of subatomic particles to several thousand times more massive than our Sun. How is it possible that something as small as a simple electron can be a black hole? That's part of the mystery that surrounds these fascinating objects. A useful analogy is to think of a bag of marbles. If you fill a bag with marbles of different sizes, you could end up with marbles as small as a pea and others as large as baseballs. Similarly, primordial black holes can have a variety of sizes, from very compact to much larger. This diversity in masses and sizes raises important questions about how and why they formed. The distribution of these primordial black holes in the universe is another intriguing question. Some scientists believe they could be spread throughout the cosmos, acting as hidden pieces in a cosmic puzzle. Others suggest they could concentrate in certain regions of space, like galaxy clusters. What role do they play in the fabric of the universe? Could they even be responsible for certain phenomena we observe in cosmology? The mass of a primordial black hole also influences its interaction with the environment. For example, smaller black holes, which could be of a mass similar to an asteroid, have a much lesser gravitational effect on their immediate environment. However, as they increase in size, their gravitational influence becomes more significant, affecting the surrounding matter. Imagine throwing a small stone in a pond compared to throwing a large rock. The impact and the waves generated are very different. Theory suggests that these black holes could be responsible for phenomena like gravitational waves, which are small disturbances in space-time caused by massive events. Could primordial black holes be the little giants that originate these waves? The answer to this question could change our understanding of physics and cosmology. Scientists are also exploring how the mass and size of primordial black holes could relate to other aspects of the universe, like dark matter. Dark matter is that mysterious part of the universe that we can't see, but seems to have a huge impact on the structure and behavior of galaxies. Could primordial black holes be a component of this dark matter, contributing to its total mass? As we advance in research, one question that persists is how we can detect these black holes. Since they do not emit light and are invisible in the electromagnetic spectrum, we must rely on their gravitational effects and how they interact with their environment. This approach is like trying to discover a fish in a pond just by observing the ripples on the water's surface. The search for primordial black holes also raises questions about the evolution of the universe. If these black holes have existed since the beginning of the cosmos formation, they could have influenced the way galaxies and other structures developed. What role did they play in orchestrating the cosmic symphony we know today? Primordial black holes, in addition to being intriguing for their variety of masses, are also a testament to the incredible environment of the early universe. The existence of these objects leads us to reflect on how they formed and how they have influenced what we are today. Each discovery about their nature brings us one step closer to solving the great mysteries of cosmology. In conclusion, the exploration of the sizes and masses of primordial black holes is not only a journey into the heart of theoretical physics, but also a journey towards understanding ourselves and the universe we inhabit. Each new piece of information adds another layer to our understanding, revealing a cosmic landscape that is both fascinating and complex. Curiosity about these mysteries drives us to continue investigating, seeking answers that allow us to unravel the secrets of creation and existence itself. Where are the primordial black holes located? This question might seem simple, but the answer is far more fascinating than one might imagine. These mysterious objects, which were formed at the dawn of the universe, have been eluding our detection for billions of years. Despite their elusive nature, there are clues that can guide us towards their location. To begin with, we should think of the universe as a vast ocean where primordial black holes are like hidden small islands. Unlike black holes that form from massive stars, which are generally found in the center of galaxies, primordial black holes could be distributed quite evenly throughout space. Imagining this leads us to wonder, could they be floating in the void between galaxies, or do they cluster in certain regions of the cosmos? One of the ways we try to locate them is through their gravitational influence. These black holes, although small compared to their stellar counterparts, have a gravitational force that can affect the matter around them. Think of a primordial black hole like a stone in a pond. Its presence creates waves that can be detected. If a star passes close to one of these black holes, its trajectory can be altered, revealing the presence of the hole through its gravitational effect. It's also worth mentioning that, being possibly smaller than conventional black holes, their detection becomes an even greater challenge. How can we find someone who is smaller than the rest of the crowd? Sometimes they can be indirectly detected through phenomena such as gravitational microlensing. This effect occurs when the light from a distant star bends as it passes near a primordial black hole, as if it were a lens. Imagine you're looking through a water bottle. The water distorts the light you see. Thus, the light from that star is altered, and with it, the presence of the black hole is revealed. Gravitational waves are another tool in our arsenal for the search for primordial black holes. These are waves in the fabric of space-time that are generated by violent events in the universe, such as the merging of black holes. If gravitational waves are detected from events involving primordial black holes, we could have a valuable clue about their existence and location. However, it's not just about finding these black holes, but also understanding where they might be. Theoretical models suggest that they could have survived in different environments of the universe. Some might be in the darkness of intergalactic space, while others might be in the vicinity of forming galaxies, where their gravitational influence could have played a role in the creation of larger structures. Dark matter also comes into play in this equation. Many scientists believe that primordial black holes could be a part of the mysterious dark matter that makes up a large proportion of the universe. If this is true, it could be that they are closer than we think, hidden in the dark matter halo that surrounds galaxies. The search for primordial black holes is also a race involving many nations and research teams. From X-ray telescopes to gravitational wave detection experiments, the scientific community is united in its attempt to unravel this cosmic mystery. What discoveries will the future bring? Primordial black holes are like shadows in the vastness of space. Their presence is felt, but their shape and location are difficult to discern. Each new discovery about their location could change our understanding of the universe and how it has developed over the eons. The exploration of these objects also raises intriguing questions about the nature of time and space. Could primordial black holes be key to understanding the history of the universe? Each answer we find leads us to new questions, and the search never seems to end. So, as we continue to search, it's important to remember that each small finding is a step towards a greater understanding of our reality. Science advances not only through great discoveries, but also through the accumulation of knowledge that brings us ever closer to unraveling the mysteries of the universe. Can you imagine what we might discover in the coming years? The search for primordial black holes is just the beginning of a journey that could take us to the depths of the cosmos, where there is still much to explore and learn. What happens when a primordial black hole encounters surrounding matter? To understand this, it's useful to think of a magnet attracting metallic objects. Just as the magnet exerts a force on nearby metals, A primordial black hole influences the matter around it in a very intense and unique way. But what does this mean in terms of the matter and radiation affected by its presence? Primordial black holes are in essence massive gravitational attractions that can influence their surroundings in surprising ways. When matter approaches a black hole, it begins to orbit around it, forming what is known as an accretion disk. This disk is composed of gas, dust, and any other nearby material, and as the matter adheres and heats up, it emits radiation in the form of light. Imagine a kind of cosmic dance where stars and gas spin around an invisible center, all being drawn in by the gravitational force of this mysterious black hole. It's fascinating to think about how matter behaves under these circumstances. As it approaches the black hole, the speed increases, and with it, friction generates extreme heat. This phenomenon is similar to rubbing your hands quickly. Friction causes heat. In the case of accretion disks, this energy is transformed into bright light and other forms of radiation, which can be detected. But what happens to the matter that can't escape? The gravity of a black hole is so intense that once matter crosses what is known as the event horizon, it can no longer return. This is like a one-way tunnel, where everything that enters is trapped forever. However, before crossing that threshold, matter can be torn apart and shattered by extreme gravitational forces. This process is known as spaghettification, and it is one of the most dramatic consequences of approaching a black hole. Can you imagine being stretched and crushed like spaghetti? Now, what effect do these primordial black holes have on the universe on a large scale? It is believed that they can influence the formation of cosmic structures, such as galaxies and galaxy clusters. By attracting matter towards them, primordial black holes could help shape the distribution of large-scale matter. This is comparable to how a dynamo in a water stream can create whirlpools that affect the movement of the water around. In addition, it has been observed that primordial black holes can interact with dark matter. Some theories suggest that they could be a component of this mysterious substance that makes up a large part of the universe. Thus, these black holes are not just simple solitary entities, but could play a crucial role in the structure of the cosmos, acting as bridges between visible matter and dark matter. But is it possible to detect these primordial black holes and their effects on surrounding matter? Astronomers are constantly looking for signals of their existence, using telescopes and other instruments to observe the radiation emitted by the accretion disks. The detection of gravitational waves, which are waves in the fabric of space-time caused by massive events, has also become a key method for searching for black holes and understanding their influence on the universe. Although we cannot directly see a primordial black hole, its effect on nearby matter gives us clues about its existence. Astronomers have proposed different methods to identify these entities, from observing X-rays to analysing stellar movements. Can you imagine being a scientist trying to unravel the secrets of the universe using only light and other clues left by these dark holes? In summary, primordial black holes have a profound impact on the matter around them. Through their gravitational attraction, they create accretion disks and generate radiation that we can detect. Their influence goes beyond what we can directly observe, affecting the formation of galaxies and the relationship with dark matter. As scientists continue to explore these mysteries, the understanding of how primordial black holes interact with the universe continues to expand, opening new doors to fundamental questions about the nature of the cosmos. Human curiosity drives us to continue investigating, seeking answers to questions that often may seem as dark as the black holes themselves. What other secrets does the universe hold in its vast complexity? What discoveries are yet to come in our quest to understand these cosmic phenomena? The adventure continues, and each new finding brings us one step closer to unraveling the mysteries of the universe. The connection between primordial black holes and dark matter is a fascinating topic that has captured the attention of scientists and curious minds alike. Can these mysterious objects be considered a fundamental part of the cosmic puzzle that surrounds us? To understand this, we must first remember that dark matter, although we do not see it, constitutes approximately 25% of the mass and energy of the universe. But what exactly is it, and how does it relate to primordial black holes? Dark matter does not emit, absorb or reflect light, which makes it virtually invisible to our telescopes. However, we know it's there thanks to its gravitational influence on visible matter, such as stars and galaxies. It's as if you had a large bowling ball in a dark room. Even though you can't see it, you can feel its weight and how it affects the things around it. In this case, primordial black holes could be the bowling balls that help shape the structure of the universe. There are several theories suggesting that primordial black holes could be a form of dark matter. But how? Imagine that, in the earliest moments of the universe, these black holes formed due to fluctuations in density. Instead of collapsing into stars, some of these dense regions could have turned into primordial black holes that could be floating in the cosmos today. If this is true, it would be a monumental finding that would change our understanding of dark matter. Another intriguing aspect of this connection is that primordial black holes could help explain some of the mysterious features of dark matter. For example, the distribution of dark matter in the universe does not seem to follow the patterns we would expect. If primordial black holes are responsible for part of this dark matter, they could be the key to unraveling this enigma. Their presence could influence how galaxies cluster and how they move in space. Furthermore, the interaction of primordial black holes with visible matter could give rise to fascinating phenomena. Can you imagine what it would be like if, when approaching a primordial black hole, the matter around it began to glow intensely? This could happen due to the intense gravity these holes exert, creating accretion disks that emit radiation. This type of activity could be a vital clue to detecting primordial black holes, and therefore studying dark matter. As scientists continue to explore these ideas, experiments have been proposed that could help test the relationship between primordial black holes and dark matter. One of them is the analysis of gravitational waves. When two black holes merge, they generate waves that can be detected by sensitive instruments on Earth. If evidence of primordial black holes is found through this method, we could be facing a discovery that would radically change our understanding of the universe. However, there are still many unanswered questions. Could primordial black holes be responsible for the formation of galactic structures? Or could their existence influence the expansion of the universe? These questions lead us to consider that research on primordial black holes and dark matter is still in its early stages, and each new discovery can open more paths to follow. The search for dark matter and its connection with primordial black holes is not only a topic of interest for astrophysicists, but also a journey into the unknown. As we delve into this mystery, we may wonder, what other secrets will the universe reveal to us? Are we really close to unraveling the nature of dark matter and primordial black holes, or do we still have a long way to go? Finally, it's important not to lose sight of the fact that every small advance in understanding dark matter and primordial black holes brings us one step closer to unveiling the secrets of the universe. What surprises await us in the future, and how will these revelations change our view of the cosmos? Science is advancing by leaps and bounds, and every day new questions are raised that challenge our beliefs. So let's keep curiosity alive. The more we inquire about primordial black holes and their relationship with dark matter, the more we can learn about the vast and intriguing universe in which we live. Who knows? Perhaps somewhere in the cosmos a primordial black hole is waiting to be discovered, holding within it answers to some of humanity's deepest questions. What if I told you that in the vast universe, there exist black holes that were not formed from dying stars, but were created in the first moments after the Big Bang? These are the primordial black holes, and their existence is still a fascinating mystery in modern cosmology. But how do we know they could exist? What evidence is there to support their possible formation and existence? To understand the existence of primordial black holes, it is essential to look at the origin of the universe. In the first moments after the Big Bang, the cosmos was an extremely hot and dense place. In this environment, conditions were perfect for extraordinary phenomena to occur. The theory suggests that, under certain circumstances, some density fluctuations in this primordial soup of energy and matter could have collapsed, forming these black holes which, unlike the ones we know today, do not require a massive star to be born. The idea that primordial black holes can exist is based on theoretical models that point to their formation in that brief moment of time. But what about the evidence that supports these theories? One of the most intriguing clues comes from the observation of dark matter. It is believed that primordial black holes could be a significant part of this mysterious substance that makes up most of the universe and that we cannot directly see. Dark matter does not emit light, therefore it is a true enigma. However, some scientists suggest that a fraction of this dark matter could be composed of primordial black holes, which would be smaller and less massive than their counterparts that form from stars. But how can we detect something so elusive? The answer is that, although we cannot see primordial black holes directly, there are ways to infer their existence. For example, some researchers are looking for gravitational effects on surrounding matter that could indicate the presence of these holes. When a primordial black hole passes near another object, it can influence its movement, creating patterns that telescopes could pick up. In addition, gravitational waves, those vibrations in the fabric of space-time that could be generated by the merger of primordial black holes, are being studied. The connection with dark matter is not the only thread that ties primordial black holes to the universe. There are theories that suggest that these holes could have influenced the formation of the first structures of the cosmos. Imagine a giant that, as it moves, drags everything in its path. Similarly, primordial black holes, being so massive, could have acted as cores around which galaxies and star clusters formed. The existence of primordial black holes proposes a new paradigm in our understanding of the universe. However, it also raises intriguing questions. If they exist, why haven't we found them yet? Is it possible that they are too small or of such light masses that their detection eludes us? These questions are at the center of current research in cosmology. Some models suggest that primordial black holes could be more common than we think, but their size and mass vary greatly. From the tiniest, which could be as light as an asteroid, to others that could rival the largest black holes we know. This variety of sizes implies that their effect on the universe could also be diverse, affecting matter and radiation in ways we do not fully understand yet. In the realm of theoretical physics, primordial black holes offer a fertile field to explore new theories. Their existence could challenge us to rethink our ideas about gravity, dark matter, and the evolution of the cosmos. What if, instead of being a simple product of the death of massive stars, black holes formed an essential part of the fabric of the universe? As researchers continue their efforts to find tangible evidence of these enigmatic objects, new theories also emerge. Some scientists have proposed that we could detect traces of their existence in the background radiation of the universe, the light left from the Big Bang. This could provide us with clues about how and when they formed, and how they influenced the structure of the cosmos. The search for primordial black holes is a collaborative effort, bringing together astrophysicists, cosmologists, and mathematicians in an attempt to unravel the mysteries of the universe. Each new discovery in this area brings us a little closer to answering questions that have persisted for centuries. Could these primordial black holes be the key to understanding dark matter? Will they help us explain cosmic inflation and the evolution of galaxies? In conclusion, the existence of primordial black holes is one of the many open questions that modern science is trying to solve. As we continue to research and explore the cosmos, each new finding brings us closer to unveiling the secrets that still remain hidden. Human curiosity knows no bounds, and the search for these black holes could lead us to discover not only their existence, but also to better understand our place in the vast universe. What happens when a primordial black hole is found around us? How can we detect it if they are so elusive? The search for these mysterious cosmic objects has led scientists to develop innovative methods. But first, it's essential to understand what primordial black holes are and why their detection is crucial for our understanding of the universe. Imagine space is like a vast dark ocean. In this vast ocean, primordial black holes are like tiny bubbles floating. They can be so tiny that they are hard to see, and their presence can be virtually imperceptible. However, their influence is undeniable. These bubbles can affect the environment around them, and through that interaction, scientists have found ways to detect their presence. One of the most promising ways to identify primordial black holes is through gravitational waves. These waves are like the waves that form on the surface of a lake when you throw a stone. When a primordial black hole interacts with another massive object, it can cause a disturbance in space-time, creating waves that travel through the universe. Detectors, like the Laser Interferometer Gravitational Wave Observatory, known as LIGO, are designed to pick up these subtle vibrations. Isn't it fascinating to think that there are instruments that can listen to the universe? As scientists perfect these instruments, they are also exploring alternative methods. Some researchers are studying the radiation that is emitted when matter approaches a primordial black hole. This phenomenon, known as accretion radiation, can reveal valuable information about the black hole's mass and location. The matter swirling around a black hole can heat up to extremely high temperatures, emitting bright light that can be detected by telescopes. Can you imagine looking up at the sky and discovering a new black hole just by the light emitted by the matter surrounding it? In addition to gravitational waves and accretion radiation, scientists are considering the possibility that primordial black holes may leave traces in dark matter. Dark matter, which makes up about 25% of the universe, is invisible and only interacts through gravity. Some models suggest that primordial black holes could act as anchor points in dark matter, allowing astronomers to track their trail. It's like following the trail of a fish in the water. Even though you can't see it, you can notice the waves it leaves in its wake. Another intriguing method being investigated is based on observing stars close to black holes. If a primordial black hole is close enough to a star, it can exert its gravity on it, noticeably altering its orbit. Astronomers can detect these alterations and by doing so infer the presence of the black hole. This approach is similar to how a lighthouse can help a ship navigate in the dark, providing clues about the location of a hidden object. International collaboration is also playing a key role in the search for primordial black holes. Teams of scientists from around the world are working together, sharing data and resources to maximize their efforts. This collaborative approach is essential, as the detection of primordial black holes requires a significant amount of time and resources. Thinking about a team of cosmic detectives working together to solve the mystery of the universe is exciting. As we advance in technology and detection methods, new questions arise. What would happen if we found a primordial black hole? How would that change our understanding of the cosmos? The possibility of discovering these objects could open new doors in physics and cosmology, challenging our current notions and providing us with answers to questions that have intrigued scientists for decades. The scientific community also faces a fundamental challenge: how to differentiate between primordial black holes and other types of black holes. With so many variables at play, accuracy will be key. Researchers must be meticulous, ensuring that every observation and every piece of data are analysed with the utmost rigour. It's a game of patience and precision, where every small advance is a step forward in understanding the universe. And what about the future of primordial black hole detection? As new technologies are developed, even more innovative methods are likely to emerge. Artificial intelligence, for example, could play a crucial role in identifying patterns in large datasets. This could facilitate the detection of primordial black holes that would otherwise go unnoticed in the noise of the universe. the search for primordial black holes is not only limited to detection, but also to the interpretation of the data obtained. Each discovery can lead to new theories and questions, creating an endless cycle of exploration and discovery. Human curiosity, driven by the quest for knowledge, is the force that drives scientists to keep going, even in the face of uncertainty. The importance of detecting primordial black holes cannot be underestimated. Their existence could have significant implications for our understanding of dark matter, galaxy formation, and the evolution of the universe. Each new finding could be a piece of the cosmic puzzle, helping us understand not only what primordial black holes are, but also how they fit into the history of the universe. In conclusion, the detection of primordial black holes is a constantly evolving field. With each new technological advance and each international collaboration, we are closer to unraveling the mysteries surrounding these fascinating cosmic objects. The curiosity and perseverance of the scientific community will guide us on this exciting journey through the cosmos. So, keeping our eyes wide open and our minds curious is essential, because the next big revelation could be just around the corner, waiting to be discovered in the depths of the universe. Primordial black holes are one of the most intriguing wonders of the universe, and their relationship with cosmic inflation is a fascinating topic that deserves to be explored. But what exactly is cosmic inflation, and how does it connect with these mysterious objects? Essentially, cosmic inflation is a theory suggesting that in the earliest moments after the Big Bang, the universe underwent an extremely rapid expansion, as if it had been inflated like a balloon. During this brief period of time, the necessary conditions were created for large-scale structures to form, such as galaxies and clusters of galaxies. Now imagine that primordial black holes are like the seeds left after a great burst of energy. When the universe expanded rapidly, these seeds could form more efficiently than the black holes we see today, which originate from massive stars that have exhausted their fuel. This means that primordial black holes could be older and more diverse in their formation than conventional black holes. But what role do they play in the evolution of the universe? Primordial black holes could have influenced the way matter grouped together after inflation. Being extremely dense objects, their gravity could have acted like a magnet, attracting surrounding matter and helping to form the first galaxies. Imagine you're at a party where there's a group of people, the matter, and a very charismatic person, the primordial black hole, who attract everyone around them. That gravitational attraction could have been essential for galaxies to start forming in the vast void of space. On the other hand, cosmic inflation also creates a context in which primordial black holes could have arisen from quantum fluctuations. In this sense, inflation created a playing field that allowed small variations in the density of matter to become primordial black holes. It's as if, in a sea of energy and matter, some points stirred more than others, forming bubbles that, when cooled, became these black holes. This opens a door to the possibility that there are many more primordial black holes than we can imagine. As the universe continued to expand and cool, these primordial black holes could have influenced the distribution of dark matter, a fundamental component of the universe that we cannot directly see. It has been suggested that primordial black holes could be a form of dark matter, balancing gravity in galaxies and helping to keep them together. But how can we be sure this is true? The connection between primordial black holes and cosmic inflation is not just a matter of theory. There are also practical implications for modern astronomy. By studying these relationships, scientists can gain clues about how the universe has developed since its earliest moments. This is like receiving a message in a bottle that tells you about a very distant time, revealing secrets about cosmic history that would otherwise remain hidden. The search for primordial black holes can also help us better understand the nature of gravity. If these black holes behave differently than conventional black holes, we could discover new facets of gravity that we had never considered before. This could open new avenues in theoretical physics and potentially lead to a unified theory that integrates general relativity with quantum mechanics. As we continue to explore the relationship between primordial black holes and cosmic inflation, it's also crucial to consider the questions that remain unanswered. How many primordial black holes really exist? What is their average size and mass? How have they affected the evolution of the galaxies we see today? Each answer leads us to new questions, creating an unending cycle of discovery and research. As technology advances, scientists are developing new methods to detect primordial black holes and study their influence on the cosmos. From using telescopes that observe cosmic background radiation to detecting gravitational waves, each new technique could give us a clearer view of how these objects intertwine with the history of the universe. In this context, primordial black holes are not just a scientific curiosity, they are a key to unlocking the mysteries of the universe. By understanding their relationship with cosmic inflation, we can begin to unravel the threads that connect the expansion of the universe with the formation of the structures we inhabit today. Each discovery brings us closer to a more complete understanding of our existence in the vast cosmos. So, as we continue to explore, research into primordial black holes and their connection with cosmic inflation reminds us that, at its core, the universe is a place full of surprises and mysteries to discover. An invitation to keep looking at the stars and wondering, what else does the universe have in store for us? Primordial black holes are fascinating creatures of the cosmos, and their influence on galaxy formation is a topic that arouses curiosity and awe. How is it possible that these invisible entities, which we can barely detect, can play such a crucial role in the architecture of the universe? To understand this, we must travel back to the dawn of the cosmos, when everything was young and chaotic. Theory suggests that in the primitive universe, there were density fluctuations in the hot plasma. These small irregularities could have been the catalyst that allowed some regions of the universe to collapse under their own gravity, giving rise to these primordial black holes. But what does this really mean? Imagine the universe as a vast ocean of energy. In this ocean, some waves are taller than others, and those larger waves could accumulate enough mass to become black holes. Thus, primordial black holes are like the first rocks in a river, sitting at the bottom, creating whirlpools that affect everything that passes by. Once formed, primordial black holes could have influenced how galaxies cluster. As these dark entities move through the cosmos, their gravity would have exerted an attraction on the surrounding matter, causing matter to accumulate and bind together. This is similar to how a snowball gets bigger as it rolls down a hill, picking up more and more snow along the way. In this way, primordial black holes could have played an active role in the galaxy formation process. The influence of primordial black holes is not limited to the creation of galaxies. It has also been theorized that they could have affected the distribution of dark matter in the universe. How is this possible? Dark matter, that enigmatic substance we cannot see, could have clustered around these black holes, creating structures that would eventually become galaxies. It's as if black holes were magnets in a field of metallic dust, attracting and organizing dark matter around them. However, the relationship between primordial black holes and galaxies is not just one of attraction. There could also be a delicate balance at play. On one hand, primordial black holes could help form galaxies, but on the other hand, the enormous gravity they generate could interfere with the star formation process. In this sense, their influence could be both constructive and destructive, like an architect who can both build and demolish. Astronomers have wondered if primordial black holes could be responsible for some of the unusual features we observe in certain galaxies. Some galaxies display a surprisingly high number of young stars, which could indicate that these black holes are playing a role in the creation of new stars. In this context, one could think of primordial black holes as the engines of galactic evolution, driving the growth and transformation of galaxies. But where do primordial black holes go when galaxies form around them? As galaxies evolve, they could become trapped in their centers, becoming what we know as supermassive black holes. This raises the intriguing question of whether all the black holes we see today in the centers of galaxies could have had a primordial origin. Could they be the descendants of those first black holes that emerged in the early universe? The possibility that primordial black holes influenced the formation of large-scale structures in the universe is an expanding field of research. Science is beginning to glimpse how these mysterious entities could have woven the fabric of the cosmos. However, there are still many unanswered questions. How many primordial black holes actually exist? And how can we detect them to confirm their role in galaxy formation? As scientists continue to explore these questions, the implications of understanding the role of primordial black holes in the evolution of the universe become more evident. If it is confirmed that they influenced the formation of galaxies, this could dramatically change our view of cosmic history. Each discovery about these black holes brings us one step closer to unraveling the mysteries of the universe. The search for primordial black holes and their role in galaxy formation is an exciting journey that combines cosmology, astrophysics, and theoretical physics. The complexity of their interactions offers fertile ground for future research. By better understanding how these primordial black holes act in the cosmos, we are not only learning about our universe, but also about the very nature of reality itself. Thus, the story of primordial black holes is a story of connection and transformation, a plot that intertwines the fate of entire galaxies. Human curiosity has led scientists to explore these mysteries, and the search for answers is just beginning. In this vast universe, there is always more to discover, and each question that is answered opens the door to new questions and new horizons, Primordial black holes are a fascinating enigma in the universe, but what implications do they have in theoretical physics? When we think of black holes, we often imagine massive star collapses at the end of their lives. However, primordial black holes are different. They are believed to have formed in the immediate moments after the Big Bang, and their nature could provide clues about the fundamentals of the cosmos. Since the emergence of Einstein's theory of relativity, physics has sought to unify general relativity with quantum mechanics. As we explore the world of primordial black holes, we find ourselves at the frontier of both theories. What would happen if these black holes could help us understand how gravity behaves at quantum scales? The existence of these objects could offer a new perspective on quantum gravity, an area that's still filled with mysteries. When thinking about quantum gravity, we are faced with the question of how extremely massive and dense objects behave. Primordial black holes have such a high density that, when trying to incorporate quantum mechanics, strange paradoxes arise. For example, what happens to the information that falls into a black hole? This question has challenged physicists for decades. The relationship between information and gravity is a puzzle that primordial black holes could help solve. An intriguing aspect is that if primordial black holes exist, they could be much more common than we think. This means they could influence the formation of cosmic structures, like galaxies and clusters of galaxies. How do they fit into the grand scheme of the universe? The answer to this question could reshape our understanding of the formation and evolution of the cosmos. Furthermore, the relationship between primordial black holes and dark matter is another fascinating terrain. Could these holes be one of the missing pieces in the puzzle of dark matter? Dark matter makes up about 95% of the universe, and its nature remains a mystery. If primordial black holes constitute part of this dark matter, we are facing a revolution in our view of the universe. The idea that primordial black holes could essentially be a form of dark matter opens the door to new theories. Imagine a universe where these holes are not only objects of study, but also keys to understanding other cosmic phenomena. For example, they could influence the expansion of the universe, challenging our conceptions about dark energy and cosmic acceleration. Primordial black holes also challenge the notion that only large and massive black holes have an impact on the cosmos. What would happen if the smaller ones had significant effects on the structure of space-time? The notion that size and mass may not be the only factors to consider could open new avenues of research in theoretical physics. In the realm of cosmology, the existence of these black holes could provide a broader context for cosmic inflation. How do they relate to the rapid expansion of the universe in its beginnings? This could lead to revisions in our understanding of how and why the universe took the form it has today. The search for a unified theory that combines relativity and quantum mechanics is one of the great challenges of modern physics. Primordial black holes could be a crucial link in this search. By studying their nature and properties, scientists could discover new laws that govern the universe, facilitating a deeper understanding of the phenomena that surround us. It's fascinating to think that in the study of primordial black holes, we are not only seeking answers about these mysterious objects, We are exploring the deepest questions about the existence of the universe itself. Every discovery in this field could be a clue that brings us closer to answering questions that have intrigued humanity for centuries. In this context, it is vital to recognize that research on primordial black holes remains an active and evolving topic. New theories and experiments are underway, and each advance could dramatically change our understanding. What surprises does the future hold in this exploration? Scientific curiosity is a powerful engine that drives the advancement of knowledge. In conclusion, primordial black holes are more than just an astronomical phenomenon. They are a battleground for ideas in theoretical physics and cosmology. Every discovery about them not only brings us closer to understanding their nature, but could also redefine our understanding of the universe as a whole. The fascination with these mysterious objects invites us to keep inquiring, asking, and above all, marveling at the complexity of the cosmos. Primordial black holes have captured the imagination of scientists and science enthusiasts alike, but their presence in popular culture is equally fascinating. From science fiction novels to movies and series, these mysterious cosmic objects have been depicted in ways that make us ponder their nature. But why are they so intriguing, and how have they influenced the creativity of writers and filmmakers over time? One of the most famous representations of primordial black holes is found in science fiction literature. Authors like Arthur C. Clarke have used black hole concepts to explore the notion of time travel and alternate dimensions. In their works, the black hole becomes a portal, a path to the unknown. This leads us to wonder, are we projecting our hopes and fears onto these fascinating phenomena? The answer seems to be a resounding yes. The mystery surrounding primordial black holes offers a blank canvas for writers to explore ideas that go beyond our current understanding. In cinema, movies like Interstellar have done an exceptional job introducing complex scientific concepts in a visually striking way. In this film, the black hole Gargantua is not just a plot element, but a character in itself. The way it is depicted, with its bright accretion disk and intense gravitation, makes us feel the immensity of its power. But what about the scientific accuracy of these representations? Although there are artistic licenses, the basic concepts about the physics of primordial black holes have been maintained, allowing the audience to at least glimpse the reality behind the spectacle. Television has also played a significant role in popularizing the idea of primordial black holes. Series like Doctor Who have explored these cosmic phenomena in plots that combine adventure and science. Often, the black hole is presented as an enemy or an obstacle that the characters must overcome. This raises an interesting question. Are black holes really something to fear, or are they an opportunity to learn about the universe? Perhaps the answer lies in how we choose to interpret them in our stories. Video games, on the other hand, have integrated primordial black holes into their narratives and gameplay mechanics. In titles like No Man's Sky, black holes are presented as portals that allow players to travel between galaxies. This interactive representation allows players to experience the physics of black holes in a unique way. Isn't it exciting to think that, like the characters in our favourite stories, we too could explore the cosmos and its mysteries? However, the fascination with primordial black holes is not limited to science fiction. They have also been addressed in documentaries that aim to educate the public about their nature and place in the universe. These documentaries often combine interviews with scientists and animations that illustrate complex concepts in an accessible way. This makes us wonder, how can visual representations help demystify concepts that seem so far removed from our everyday reality? In addition to literature, film and video games, primordial black holes have found their way into music. Artists and bands have used black hole-related metaphors in their lyrics to explore themes of loss, love, and the passage of time. The lyrics can evoke the idea of a black hole as a place where everything we know is lost, leading to deep reflection on our own existence. It's intriguing to think about how such a complex phenomenon can serve as inspiration for art. Science has also influenced how primordial black holes are represented in popular culture. As we advance in our understanding of physics and cosmology, writers and content creators have adjusted their narratives to reflect these discoveries. This raises the question of whether science and fiction are in constant dialogue, each feeding off the other. Could it be that the stories we tell influence the direction of scientific research? Social media has broadened the discussion about primordial black holes, turning them into a viral phenomenon. Memes and short videos have allowed complex concepts to spread quickly among the general public. This democratization of scientific knowledge is exciting, but it also raises questions about the accuracy of the information being shared. Are we really understanding the science behind these concepts, or just enjoying the entertainment? In the end, the representation of primordial black holes in popular culture is a reflection of our innate curiosity about the universe. Every story, every movie, and every song that mentions them reminds us that there is much more to discover. It invites us to keep questioning, exploring, and learning. After all, in a universe so vast and mysterious, there will always be new secrets to unveil. The way primordial black holes are addressed in popular culture also provides an opportunity to reflect on the relationship between science and imagination. The ability of creators to transform complex scientific concepts into accessible narratives helps us connect with ideas that might otherwise seem distant. In a world where science is advancing by leaps and bounds, it is essential that we continue to foster this connection between science and art. Finally, in exploring how primordial black holes have influenced our culture, we must not forget that these representations are a reminder of our own quest for knowledge. They invite us to look at the stars and wonder, what else is out there? Curiosity is a powerful force, and as long as we keep looking towards the cosmos, the story of primordial black holes and their place in our culture will only continue to grow. What are primordial black holes, and how can we study them? These questions lead us to a fascinating world of experiments and simulations that seek to unravel the mysteries of these enigmatic cosmic objects. In the quest to understand primordial black holes, the scientific community has devised various strategies that combine theory with observation. But how is this research carried out? One of the most intriguing ways to study primordial black holes is through computer simulations. Imagine you're creating a universe on your computer where every particle of matter, every ray of light, and every black hole are accurately modelled. These simulations allow scientists to observe how primordial black holes behave in different scenarios, from their formation to their interaction with other cosmic objects. Just like a film director creating a story with complex characters and plots, physicists use these tools to narrate the story of the universe. Through these simulations, questions such as, what would happen if a primordial black hole passed near a star, can be explored. The answer could reveal information about how these black holes are distributed in the universe and how they affect surrounding matter. Researchers can adjust variables in their models, such as the mass and speed of black holes, to observe how these alterations impact the behavior of the environment and the phenomena that occur. In addition to simulations, laboratory experiments also play a crucial role. How can a black hole be recreated in a controlled environment? Although we can't create real black holes, physicists use particle accelerators to study the fundamental components of matter and the forces that could give rise to these phenomena in the universe. By colliding particles at speeds close to light, scientists attempt to recreate the conditions of the early universe, where primordial black holes might have formed. The detection of gravitational waves is another frontier in primordial black hole research. When two black holes collide, the disturbance in space-time generates gravitational waves that can be detected by instruments like LIGO and Virgo. These waves are like echoes of the universe, telling us stories about events that occurred billions of years ago. If gravitational waves from primordial black holes were detected, it would be a revolutionary discovery confirming their existence. The search for radiation is also a fascinating method. Although black holes do not emit light, they can interact with the matter around them, generating radiation in the process. By studying this radiation, scientists can gain clues about the mass and behavior of primordial black holes. Just like a forensic investigator examines the traces left at a crime scene, astrophysicists analyze the signature these objects leave in space. It seems that the detection of primordial black holes is a puzzle that requires multiple pieces. For example, high-end telescopes are designed to capture light from distant objects, but they can also help identify the influence of these holes on their environment. When a primordial black hole traps matter, it can heat it to extreme temperatures, generating flashes of light that can be observed. This is an approach that combines direct observation with theoretical inference. Here's where the concept of dark matter comes into play. Some scientists suggest that primordial black holes could be a significant component of dark matter, which, although we can't see, makes up nearly 25% of the universe. Simulations and experiments are underway to investigate whether these black holes could be part of the solution to the dark matter mystery. Imagining a universe where primordial black holes and dark matter are intertwined is truly fascinating. International collaboration is also an essential aspect of this research. Teams of scientists from different countries share data, resources, and knowledge. Just like a sports team working together to win a championship, physicists and astrophysicists are joining forces to solve the mysteries of primordial black holes. Each discovery, each simulation, each experiment brings a new piece to the puzzle. Research on primordial black holes is not only a fascinating field of study, but it also raises questions about our understanding of the universe. As simulations and experiments advance, the horizon of what we know expands, revealing new dimensions of reality. Human curiosity, driven by the desire to understand the unknown, remains the engine that drives this research. And what does the future hold? Technology is advancing by leaps and bounds, and with each new instrument developed, new opportunities open up to discover more about primordial black holes. Each advance in gravitational wave detection, each improvement in telescope capabilities, brings us a little closer to understanding the nature of these objects. So the next time you look at the starry sky, think about primordial black holes and the exciting scientific quest that is underway to understand them. Perhaps one day, thanks to experiments and simulations, we will not only discover their existence, but also the fundamental role they play in the vast cosmos. Science continues its journey, and we are witnesses to each step in this intriguing adventure. What if I told you that primordial black holes are not only a fascinating topic in astrophysics, but they could also change our way of understanding the structure of the universe? In the quest for knowledge, these mysterious objects have begun to take a central place in modern cosmology. But why are they so important? The answer lies in their potential to solve some of the greatest enigmas of the cosmos. Primordial black holes are like missing pieces in a cosmic puzzle. They are believed to have formed shortly after the Big Bang, at a time when the conditions of the universe were extremely chaotic and dense. But how can these objects, which are so ancient, influence the current universe? The key is in their ability to interact with the matter and energy around them, creating effects that can be observable even billions of years after their formation. Research on primordial black holes has opened a Pandora's box in cosmology. By studying their existence, scientists are exploring new theories about dark matter, an essential component of the universe that we do not fully understand yet. Imagine that primordial black holes are like detectives in a mystery novel. Their presence could be the clue we need to discover who is really responsible for the lack of visible matter in the cosmos. In a broader sense, primordial black holes are challenging our notions about gravity and physics in general. They are forcing us to question what we know and to expand the limits of our understanding. In this process, new connections are being forged between different branches of physics, such as relativity and quantum mechanics. What if these interactions lead us to discover a new unifying theory? The search for these black holes has also driven the development of new technologies and observation methods. With each new advance, we are closer to obtaining concrete evidence of their existence. Imagine that each small discovery is like a spark that illuminates the darkness of space. Each step we take on this path brings us closer to better understanding the universe and our place in it. However, there is one aspect that we should not overlook. The scientific community is tirelessly working to answer questions that have remained in the shadows for decades. Are primordial black holes really responsible for dark matter? What role do they play in the formation of galaxies? These questions are like magnets attracting researchers from all over the world who feel driven to contribute to this exciting field of study. The impact of primordial black holes on modern cosmology is like a wave spreading in a pond. Each new discovery generates more questions and more interest in the implications of these objects. The scientific community is at a turning point, where each answer can open the door to new theories and explorations. Human curiosity is at its peak, and the universe seems to be saying, there is much more to discover. The implications of research on primordial black holes are vast and varied, from understanding how galaxies were formed to the very nature of time and space. These objects are at the center of debates that could shape the future of physics. So, what is the next frontier in this quest? The answer could be more surprising than we imagine. As we move forward in the study of primordial black holes, it is essential to keep an open mind and be willing to accept that what we think we know could change. Science is a continuous journey of discovery, and each new finding can result in a revolution in our understanding of the cosmos. Although there are still many unknowns, the enthusiasm to unravel them is palpable in the scientific community. In this exciting path forward, it is essential to recognize the role of each researcher, each working team, and each institution that has contributed to the advancement of knowledge about primordial black holes. Their dedication and passion are what allows science to continue advancing and human curiosity to remain unquenched. Lastly, let's reflect on the future. As technologies continue to improve and detection methods become more sophisticated, our ability to explore these mysterious objects will only increase. Primordial black holes are not just a phenomenon of the past. They are a window into the future of cosmology, a future full of infinite possibilities. So, as we continue to delve into the depths of the universe, let's remember that each question we ask and each answer we find are steps towards a deeper understanding of the reality that surrounds us. In this cosmic odyssey, primordial black holes are our guides, pointing us the way to the unknown. The search for answers about primordial black holes has opened up a world of fascinating questions. What secrets do they hold in their dark interior? These mysterious objects not only lead us to question the nature of the universe, but also the very essence of reality itself. If primordial black holes truly exist, what implications would this have for our understanding of the cosmos? One of the most intriguing enigmas is the role they could play in the formation of large-scale structures in the universe. Are they capable of influencing the creation of galaxies? Imagine an invisible magnet attracting everything around it. This could be a way to visualize how a primordial black hole could affect surrounding matter, shaping the fabric of the universe itself. The idea that these objects could be crucial in the evolution of the cosmos is both exciting and bewildering. Another fascinating aspect is the potential connection between primordial black holes and dark matter. Could these black holes be a form of dark matter, or even its main constituent? Dark matter, which makes up a large part of the universe's mass, behaves strangely. If primordial black holes are part of this puzzle, we would have to rethink our view of how matter interacts in the cosmos. The possibility that such an enigmatic object as a primordial black hole is part of an even larger phenomenon is undoubtedly a fascinating topic of exploration. Speaking of exploration, Questions about the very existence of primordial black holes lead us to another concern. What evidence do we have of their existence? Despite decades of research, scientists are still looking for evidence to support the theory that these black holes are among us. The absence of evidence does not necessarily imply that they do not exist. In science, often, the most impactful answers are found in the most unexpected places. Could we be looking in the wrong direction? And as for the deeper questions, there is one that resonates in many minds. If primordial black holes exist, what does that mean for the laws of physics? From relativity to quantum mechanics, each theory has its own way of describing the universe. However, primordial black holes could challenge them. Imagine it as a new type of puzzle that does not fit into the pieces we already have. This could open the door to a new era of discovery and understanding. Human curiosity has always been the driving force behind progress. In the quest to understand these phenomena, scientists have conducted simulations and experiments that challenge our current understanding. However, each discovery brings with it more questions. How much more do we have to learn? Research on primordial black holes could unveil secrets that have been hidden since the dawn of time. Moreover, we cannot ignore the fact that as we advance in the search for answers, we must also consider the limits of our knowledge. What questions have we not yet asked? Science advances by leaps and bounds, but there is always a new horizon to explore. The unanswered questions about primordial black holes are numerous, from their formation to their impact on the structure of the universe. Each answer we find generates new unknowns that require our attention. The scientific community is constantly searching for tools and methods to unravel these mysteries. With the development of new technologies such as more powerful telescopes and gravitational wave detectors, we are closer than ever to getting answers. But will it be enough? Science is a journey, and often the paths we take are as important as the destinations we reach. Meanwhile, imagination plays a crucial role in science. The theories and models we propose are, in part, the result of our ability to dream. What will happen when we finally manage to observe a primordial black hole? The revelation could be a milestone that transforms our understanding of the universe. From the creation of new theories to the re-evaluation of existing ones, the implications could be enormous. However, not everything is clear on this journey. There are barriers we must overcome, and not all questions have immediate answers. Uncertainty is an inherent part of the scientific process. What happens if we never find a definitive answer about primordial black holes? Sometimes the search itself becomes the goal. Human curiosity is insatiable, and as long as we keep exploring, there will always be a new challenge to face. The history of science is full of moments when the unknown becomes knowledge. Each discovery about primordial black holes could be a step towards understanding the mysteries of the universe. Although the answers may seem elusive, what really matters is the path we choose to follow in our quest for truth. So, as we reflect on these unanswered questions, let's remember that the universe is a vast ocean of enigmas. Primordial black holes are just one of the many wonders that await us. Curiosity and the desire to understand are what drive us forward, and in this quest, we are likely to find not only answers, but also new questions that will lead us to a deeper sense of wonder. In conclusion, although not all questions about primordial black holes have an answer at this time, the journey towards their discovery is what truly enriches our understanding of the cosmos. Who knows what wonders await us around the corner? Science is an adventure, and each question is an invitation to keep exploring. A thought-provoking cosmic illustration depicting the intersection of primordial black holes and theoretical physics, with equations and cosmic elements intertwined. From the detection of gravitational waves to advances in next-generation telescopes, the tools at our disposal are rapidly evolving. Imagine that we are at a turning point where each new technological advance is like a new piece of a cosmic puzzle. Each time a researcher delves into the study of these phenomena, they get a little closer to solving the enigma of their existence. International collaboration has been key in this process. Teams of scientists from around the world are working together, sharing data and theories, as if they were building a huge bridge between different cultures and approaches. This not only broadens the scope of research, but also enriches the discussion about primordial black holes and their role in cosmology. Can you imagine what could emerge from this global collaboration? One of the big questions that persists is, could primordial black holes be the key to understanding dark matter? Many researchers are exploring this possibility, looking for connections that could revolutionize our current theories. Dark matter is an essential component of the universe, but it remains a mystery. If we manage to establish a link with primordial black holes, we could open a new door to understanding the structure of the cosmos. In this context, research does not stop. New theories are constantly emerging, and scientists are formulating bold hypotheses. Could it be that primordial black holes play a role in cosmic inflation, that rapid expansion of the universe after the Big Bang? If this is confirmed, it could radically change our view of how galaxies formed and evolved. In addition, computer simulations are playing a fundamental role in research. These models allow scientists to observe how primordial black holes might interact with their environment. Who would say that simple lines of code could offer glimpses into the most extreme events of the universe? This innovative approach is allowing researchers to predict behaviors and phenomena that we have not yet been able to observe directly. Observations are also at the center of attention. With advanced telescopes and gravitational wave detectors, scientists are on the hunt for evidence to support the existence of these black holes. Can you imagine the moment when one of them is detected? It would be like finding a hidden treasure in a vast ocean of stars. Each attempt at detection is like casting a net in search of clues that could confirm or challenge what we already know. However, the road to discovery is full of challenges. The very nature of primordial black holes makes them difficult to study. Their existence could be ephemeral, and the evidence of their presence can be subtle and elusive. But that does not stop the scientific community. On the contrary, it is precisely this difficulty that fuels curiosity and the desire to understand. As we move forward, it is also crucial to consider the ethical and philosophical implications of discoveries about primordial black holes. What does it mean for us as a species to understand that there are objects in the universe that defy our notions of space and time? The search for these black holes is not just a scientific matter, but also raises questions about our existence and our place in the cosmos. Education and scientific outreach are equally crucial on this journey. As we discover more, it is vital that we share that knowledge with the public. How can we inspire the next generation of scientists and thinkers? The answer may lie in telling stories that connect science with imagination, showing how primordial black holes are part of a larger narrative about the universe. As we delve into the future, what new frontiers will we explore? Research on primordial black holes is a constant adventure, and each new finding can open paths that we have not even imagined today. Human curiosity is insatiable, and in the search for answers, we find even deeper questions. The story of primordial black holes is just the beginning. Each discovery not only brings us closer to better understanding these phenomena, but also reminds us of how small we are in the vast universe. Science continues to advance, and each step we take leads us to a new horizon. With perseverance, collaboration, and creativity, the future of research on primordial black holes is undoubtedly bright and full of promise. Who are the heroes in the intriguing world of primordial black holes? The answer to this question leads us to meet the scientists and teams who have dedicated years of their lives to unraveling the mysteries of the universe. From the pioneers who formulated the first theories to current researchers using cutting-edge technology, each has contributed their grain of sand in this fascinating search. One of the most prominent figures is Stephen Hawking. Although he is best known for his work on black holes in general, his influence extends to primordial black holes. Did you know that Hawking suggested that these holes could have been created at the time of the Big Bang? His theory on Hawking radiation opened new doors to understanding how black holes interact with the rest of the universe. What if I told you that, thanks to his work, we can now think of these objects not only as devourers of matter, but also as emitters of energy? We cannot forget the community of astrophysicists who have followed his example. One of the questions they ask is, how can we detect these black holes that are often invisible? Teams of scientists around the world are working hard on this challenge. Using state-of-the-art telescopes and gravitational wave technology, they search for signs of these mysterious objects. Can you imagine being part of a team that can listen to the vibrations of the universe as if you were listening to the music of the stars? As technology advances, so does our understanding. Scientists have created computer simulations that represent how these primordial black holes might behave. How is it possible that a set of numbers and algorithms can help us visualize what is millions of light years away? These simulations are like a map that guides us through the unknown, allowing us to make predictions about the existence and behavior of these black holes. One of the most exciting aspects of research is international collaboration. Did you know that many discoveries in science are the result of joint efforts between countries? Primordial black holes are no exception. Teams of scientists from different continents share data, ideas, and resources. This creates a network of knowledge that transcends borders, demonstrating that human curiosity knows no limits. What could be achieved if we all work together towards a common goal? However, not everything is easy on the path of research. Scientists also face skepticism and doubts. Some theorists have questioned the very existence of primordial black holes. But what happens when science faces controversy? Instead of giving up, researchers are driven to prove their hypotheses through evidence. Each experiment, each observation, becomes a brick in the construction of a building of knowledge. Perseverance is key in this journey. Imagine for a moment the impact that these primordial black holes could have on our understanding of the universe. What would happen if concrete evidence of their existence were found? The scientific community would be shaken, and human knowledge would advance by leaps and bounds. However, until that moment, each discovery, each new finding becomes a rung towards a deeper truth. University students also play a crucial role in this search. Many young people are drawn to the mysteries of the cosmos and dream of being part of this adventure. Who knows? Perhaps the next great theory about primordial black holes will come from the mind of a student who is still in the classroom. Science is a constantly evolving field, and each generation has the opportunity to contribute to the cosmic narrative. The work of the scientific community is not limited to research. There is also a great effort to communicate these discoveries to the general public. How many times have you seen documentaries or read articles about space that have left you amazed? Science communicators create bridges between technical knowledge and popular curiosity. Their work is vital to inspire future generations to look at the stars and wonder about what is beyond our current understanding. It is important to remember that despite the advances, there are still many unanswered questions. What else will primordial black holes reveal to us? The search for answers is what drives scientists to move forward. Each question asked is a new path towards discovery. And on this journey, the scientific community becomes a family united by curiosity and the desire to understand the universe. In addition, diversity in science is fundamental. The inclusion of different perspectives, cultures, and approaches in research enriches the process. Each voice brings a unique vision, and this is especially valuable in the study of complex phenomena like primordial black holes. What innovative ideas could emerge if more people from different backgrounds joined this search? At the end of the day, primordial black holes are more than just concepts in physics. They are a reminder of how far we have come in our understanding of the cosmos and how much we have left to discover. Each new finding, each theory, is a step forward in the vast ocean of knowledge. The scientific community, with its passion and dedication, continues to navigate this immensity, seeking answers to questions that have not yet been asked. To conclude, the story of primordial black holes is also the story of the people who have dedicated themselves to understanding them. From the pioneers to the young researchers, each has left their mark in this field. Human curiosity, driven by the search for truth, is what leads us to continue exploring the universe. And so, as we look towards the horizon of the cosmos, let's remember that we are part of a collective journey to discover the unknown. Exploring primordial black holes not only leads us to understand cosmic phenomena, but also invites us to reflect on our place in the vast universe. What are these mysterious objects that formed at the dawn of the cosmos? Throughout this video, we have unraveled their secrets, but now is the time to summarize and understand why they are so fascinating. Primordial black holes are like the ghosts of the universe's history. They formed shortly after the Big Bang, at a time when everything was chaos and energy. Imagine a universe where particles were literally dancing in a frenetic dance. In the midst of this maelstrom, some points in space began to collapse under their own gravity, creating these black holes. Their existence raises intriguing questions. Are these black holes the seeds of galaxies? Can they help us understand dark matter? We have learned that not all black holes are the same. Primordial ones differ from those that form from massive stars. While star black holes are the result of stellar life cycles, primordial ones were created in a completely different context. This contrast opens up a range of possibilities about how the universe has been structured throughout its history. The different masses and sizes of primordial black holes show us the diversity in the cosmos. Some may be as light as a mountain, while others could have the mass of several planets. What does this mean for the search for these objects? The variability in their size suggests that they may be hidden in the darkest corners of the universe, waiting to be discovered by our telescopes and detectors. When thinking about their location, it is fascinating to consider how these black holes could be scattered throughout the universe. Imagine a vast ocean, and in it small invisible islands. This is what primordial black holes are like. Their presence can influence the matter around them, but they often remain hidden, defying current detection methods. Science faces a challenge, and each new technique developed brings us closer to their identification. Primordial black holes also have an impact on the surrounding matter. Have you ever wondered how an object can attract everything that is nearby? This is what these black holes do. They create a gravitational effect that affects the stars and gas around them, forming accretion disks full of energy. These disks are like the magnets of the universe, attracting matter towards them and creating luminous phenomena that astronomers can observe. The connection between primordial black holes and dark matter is another intriguing point. Dark matter makes up a large part of the universe, but it remains a mystery. Some scientists suggest that primordial black holes could be a part of this dark matter. Could they be the missing pieces in the puzzle of the universe? The answer to this question could change our understanding of cosmology. With each theory and model we review, we realize that the existence of primordial black holes is not just a matter of curiosity, but a key element in the evolution of the cosmos. The search for indirect evidence suggesting their existence is ongoing work, and each new finding could be a step towards revealing one of the greatest unknowns of modern physics. Observations and detection methods have evolved over time, from gravitational waves to the radiation they emit. Technology becomes our ally in the hunt for these black holes. Science is a constantly changing adventure, and each discovery brings us closer to understanding how our universe was formed. Primordial black holes are also connected with the theory of cosmic inflation, an idea that suggests that the universe expanded rapidly after the Big Bang. How do these holes relate to the expansion of the cosmos? This connection could be fundamental to understanding the structure of the universe as we know it today. Their influence on the formation of galaxies is another aspect that we cannot overlook. primordial black holes could have played a crucial role in how stars grouped together and galaxies formed. Imagining how these invisible forces shaped what we see in the sky today is a fascinating exercise. Theoretical physics is also enriched by the study of these holes. Quantum gravity, for example, seeks to unite general relativity with quantum mechanics. Primordial black holes are a testing ground for these theories, challenging scientists to rethink what they believe they know about the nature of the universe. In popular culture, primordial black holes have captured the imagination of writers and filmmakers, becoming symbols of the unknown. From books to movies, their portrayal reflects our fascination with what is beyond our understanding. This curiosity is what drives science and leads us to explore the unexplored. As we advance in research, experiments and simulations become vital tools. Scientists are creating environments in which they can test theories and models about primordial black holes, trying to replicate the conditions of the early universe. This search is a testament to human tenacity and our quest for answers. Finally, it is essential to recognize the impact that the search for primordial black holes has on modern cosmology. Every small discovery leads us to new questions and a deeper understanding of the universe. Curiosity and the desire to explore the unknown are engines that drive us forward. As we close this chapter on primordial black holes, it is important to remember that many questions still remain unanswered. Science is a journey in which each answer leads us to new unknowns. Research on these fascinating cosmic objects continues to advance, and new possibilities are on the horizon. Curiosity and the desire to know the unknown are the true engines of our evolution as a species, and primordial black holes are just one of the many doors we can open on our journey towards understanding the universe.